Hello everybody, and welcome to today's presentation on what's new in nCode 12. My name is Paul Roberts and I'm the product manager for nCode, GlyphWorks and DesignLife, and today I'm going to be telling you about the new updates in our latest product. So our main three products are nCode, DesignLife, GlyphWorks and Automation, and today I'm going to be talking about a couple of general issues that affect all the products, and then in more detail on the new updates in DesignLife and GlyphWorks. One of the new changes at version 12 is the introduction of a fourth product, nCode VibeSys. I'll tell you a little bit about this over the next couple of slides, and then there'll be more information on this in a webinar next week. So if we cover that first. So VibeSys is a new product focused on the needs of acoustic and vibration engineers. So this is a new application that will appear on your left-hand menu in the nCode environment. And this version has included new work examples, a new theory guide, a complete set of standard processes to go with VibeSys, and a new vibration manager tool to manage your vibration test specifications. There's also a short introductory video available on the website. And at the moment, all current customers of the frequency module will be automatically upgraded to VibeSys base at version 12. As I mentioned, we've got 4 new worked examples that are included, so there's now a suite of 9 examples relevant to VibeSys. So this covers areas such as ride quality analysis, acoustics, exposure to noise, and modal parameter estimation. And as I said, there will be a webinar in this in a bit more detail next week on March the 10th. If you'd like to register for that, you'll get a little more information at that point. The second large change that affects all the software at 12 is the introduction of a new licensing tool. At 12, we're introducing a new license manager, and we've moved towards LMX as our license manager, and that will be our licensing tool from now on. This includes a new license administration tool with the software, and it's got some increased security and much improved usage reporting from the CDS token system. We will continue, of course, to support our previous versions with Flex, but moving all new versions to LMX. Also, at the same time, we've introduced access to our sister company ReliaSoft products. So we've introduced Frontier Access, so this extends the nCode CDS licensing system we've currently got to cover all the ReliaSoft desktop products. So this will give you access to products such as Viable and XFMEA from ReliaSoft. For those of you that don't know the ReliaSoft products, there's information there on the website. And at the bottom of the page, you can see the unit draw for each of the different modules that are supported. So this extends the current CDS licensing to cover both product portfolios now. So now in a bit more detail about the changes in DesignLife and GlyphWorks. So starting with DesignLife. So the major changes we've got in this version are introduction of a new Composite analysis option. I'll cover that in a little bit of detail over the next few slides. We've had some enhancements to the vibration fatigue, some speed and capacity improvements. We've also opened up the analysis engine a little bit more to add more custom capability. So if you want to write any of your own processes within Python to use within our tool, and some other additional enhancements and new worked examples which I'll cover as well. So looking at composite analysis to begin with. So this is a new option in DesignLife at 12. So this is separate from the short fiber analysis that we've had in there for a while. This is looking at simple safety factor, static failure criteria analysis based on industry standard failure criteria. So not a fatigue calculation, but looking at static failure criteria. So this applies to unidirectional, long fiber and woven composites, and currently supports 10 different static failure criteria, but also allows you to do a custom method. So if you want your own to program your own method, you can. And included with this also a new worked example. and includes 2 different new glyphs, which I'll cover in a second. One of the main reasons for doing this is the continued increase in the use of composite materials. So currently aerospace and wind turbines are the largest user of carbon fibre, but even automotive is now predicted to overtake those markets in terms of the amount of composites used. So it's a growing area, an area we're putting more emphasis on in terms of the analysis we can cover. This tool is actually just using known technology, so most of the standard FE solvers will have the same static failure criteria built in. But within DesignLife, it allows you to look at this load, look at the static failure criteria over the complete load history applied to the component. So you can apply your real measured loads and look at your static failure criteria for all those different load combinations. This has already been in use in the aerospace industry in beta form for the last 6 to 9 months. So there's been quite a bit of utilisation already and some improvements based on that. As you'd expect, reads all the normal native FE formats, allows you to standardise your process and use the standard industry standard failure criteria that are already used by most people, but within the DesignLife environment. Because there's currently no single agreed static failure criteria, we've covered as many as we can to start with. So in the first version there are 10 different failure criteria covered, you see there, and also the custom, which allows you to write your own in Python. These will be added to 12.1, where I think we're going to add about 3 more static failure methods. So as many as we can in terms of the typically used ones in the industry. To go along with this, we've also added a new material definition, and there's at least 1 example material from published data in the database. So this is all the different static parameters you need in order to do the different failure criteria in the material. So as I say, 1 material included in as an example. And also to help in the use of this, we've added 1 worked example. So this is based on an FE model of a wind turbine blade, layered composite model. I'll show you this as an example in a bit when I finish the slides, so you can see this in a bit more detail. Secondly, in terms of changes, we've added more functionality to the vibration solver. Up until version 12, if you wanted to do multiple simultaneous PSD loadings, you could only do that from an FRF calculation. So this meant you would need quite a lot of data from your FE file, as it would be quite large. We introduced the possibility of modal loading for the single application of a PSD at version 11, and now this has also been added for covering multiple PSDs. So now you can have a single modal stress file, multiple, in effect, load files of the participation factors, and this means your FE can be much smaller, so you can save on having a much smaller file. This makes the analysis much faster. But also you could get much better frequency resolution by increasing the resolution in the load files, but not much change in the amount of space taken up. So you can get much better frequency resolution than you would do based on a very large FE results file. So it gives you much bigger advantage in smaller files and much better resolution to your analysis as well. So this finishes the changes we made to the vibration solver in terms of multiple simultaneous PSDs. So it now enables the complete use of modal results, multiple PSD locations, application of various static loads, and also the application of the temperature load cases as well. We've also been working quite hard on speed and capacity improvements within DesignLife 12. So a couple of things to highlight. We've increased the file reading speed a little, so we've added a metadata file that we generate the first time we open an FE file. So this in effect takes all the metadata from the FE file, saves it into a much smaller XML file. This allows us to pick that up and subsequent entries to when we open the file. And this makes the use of the interface much quicker. So you can set up your job in DesignLife, look at the load cases, look at the materials, much quicker for very large models. No change to the analysis speed doing this, but much faster use of the interface, so much easier to set up when you're using it. The second change is to the addition of a fast Dang-Van algorithm. We've had the Dang-Van solver in the software for a long while. This adds a different algorithm that basically gives you much more accuracy, much faster. It's about equivalent to speed if you have the hardening parameter set quite big, but if it's that small to give you the most accurate answer, then it is up to 100 times faster in terms of the analysis. So it can speed the analysis up quite a little. We've also, I mentioned earlier, expanded the custom capability within the product. Currently, we have custom capability built within the SN engine to do your own damage models and read your own material data in. And also, within the spot weld tool, we have a custom spot weld analysis, so you can do your stress resolution from forces to stress for spot welds specifically. This is opening that up a little bit further, so it completely opens the system in terms of reading stress, strain, or vibration results in, allows you to have your own custom combination method, so your calculation of your combination stress and or your fatigue analysis algorithms. So you can use our cycle counter or your own, or you can use any combination of custom combination, your own combination, our combination, and the cycle counting capability. So it opens up a little bit more. We'll add a little bit more capability at the next version to do the plasticity modeling from your data, and then that should be virtually the entire system opened up from a Python point of view, so you can do any of your own analysis within this tool. This will be much slower, of course, but for method development and for trying out different methods, it's quite a useful capability to have. And this is in the DesignLife base, so available to all users. There is also a new work example on this as well. So there's been a couple of methods implemented, and I'll show you these in a moment when we look at the demonstration. A couple of additional changes within DesignLife. We've added some support for multi-R ratio analysis from Digimat. So if you're looking for short fiber composite analysis, you can now do multiple R ratio analysis from those materials directly from Digimat. And we've also added some improvements to the support from Altair's OptiStruct H3D file. We, of course, already support OptiStruct's OP2 output in all its capability, but we're finally adding most of the capability of all the functions within the H3D. And at OptiStruct's version 14 in our next issue, we should have all our final analysis covered when there's one extra thing that needs to be copied, that needs to be put into the H3D file. So that will then finalise all the H3D support. And as I mentioned, there are several new work examples. We've actually got 4 new work examples for DesignLife at version 12. There is a new multi-axial fatigue analysis example using the multi-axial analysis engine. We made quite a few changes to that at version 11 and 11.1, so much improved, and we've added this work example at 12 in order to make it more easy for the users to use to explain the functionality within that complex engine. The composite static failure criteria has got its own work example now. The custom analysis is its own work example with a couple of different examples of different methods that can be used. And we've also added a 4th example on using the auto elimination engine to increase your fatigue analysis speed. So making it easier to add elimination to analysis instead of doing a complex multi-run. Now I'll cover the changes to GlyphWorks, and then I'll move on to a demonstration of both of those things. So the first new thing, there's a new glyph within GlyphWorks at 12 called Stationarity Test Glyph. So this is looking at time series data to look at whether the statistics of your data are stationary throughout the time. So this currently uses the Kolmogorov-Smirnov method called KS test. So this is basically looking at the probability density functions of the data, comparing individual sections of the data to the full amount of data to see if they've changed significantly. So basically the time signal is divided into successively smaller segments, then the probability density function of each compared to the entire signal, and then statistics looked at to see whether that data is the same. And if you see the plot at the bottom of the page, you can see the green points mark where it's excessively divided as you go up the page, and then where the red ones come in is where some of the stats have deviated, so the probability density function is different for those sections. This is a test that's vital to do when using that data for doing future vibration analysis or vibration fatigue analysis, where it's a prerequisite of most of those analyses that the data is stationary and the stats don't change significantly. So this gives you a test to see whether that data is stationary and whether it can be successfully used in a subsequent fatigue analysis or vibration analysis. So a very useful glyph, and gone into the base of DesignLife for everybody to use. GlyphWorks, sorry. Some other changes to GlyphWorks 12. We've made some performance improvements. So now you can save for batch instead of from the main menu. You can do it from the user form. So if you've set your own user form up with multiple values there, you can actually set those values and then save that process from that point. So those values you've now set in your user form get set in the script and written out for batch. So this allows you to just set the values that you have defined in your user form as being important and get those to be dropped out in the script instead of all of the values that would be possible to be output. Also made quite a few changes to the XY display glyph in terms of XY display zoom in, added per channel X and Y cursors, also being able to load those from metadata. The file format plugin has been improved, and we've now added the pick function button, which was always available on time series calculator, also onto multi-column and metadata calculator glyphs, just making those a little bit easier to use. So you don't have to remember what all the function names are now, you can input them from a button. And we've continued to add file format support. So this version we've added an ACRA PCAP format. This is a bus type structure format used in the aerospace industry, and also support for an Adams car format. We've always, quite a long while, supported the Adams rec format, which is the output from Adams, but Adams car adds an extra file to this with more information in on the data, more metadata. So we now have support for that as well. So that can be picked up and added more detailed channel information. So that's the main focus of the product update so far. If I just now share my screen. So we'll cover the composite static failure glyph to start with. So this is a new DesignLife glyph. This will allow you to analyze composite components and look at static failure criteria. So if we have a look at the analysis engine itself, basically you have a failure envelope possibility where you can pick a single failure criteria. So I can pick one of these if that is the criteria you want to choose, but I can also pick conservative. If I pick conservative, I can select as many of these different failure criteria as I want, and it will give you the most conservative result based on all of those different different criteria. So if I just run this to show the results. So we look in the two outputs. Basically, the bottom one you see here, I have a complete analysis using worst case failure criteria. So this is doing a conservative analysis and giving you the worst case result. And then I can look at the hotspots for that analysis and see in a bit of detail where my failures are. But you can also look at any individual results. So you've got the results for all the different failure criteria you've selected, and you can select any of those to look at individually to see which is the worst one. we've also added the failure criteria glyph you see here. This will basically generate a map of the failure criteria you select, and it will allow you to plot in the XY display glyph the failure criteria you see in grey against the stress applied to the stress you see from the particular point. So I'm exporting the stress for the worst point, and then I'm comparing it with the failure criteria to see whether I'm outside the bounds of that criteria. So it just gives you another graphical way of looking at those results. Secondly to that, I've also got the custom failure criteria. So exactly the same flow process. This is using the one that's in the worked example. But now I've got custom criteria true, so you have to turn that on, and then you get a drop-down list of all the custom criteria you've defined. So currently I'm just picking max stress. So this is simulating the max stress criterion we've got just in the example. And in this you can add additional parameters. So any of your new methods you define, you can define your own set of parameters. So if you need to pull in different material data, you can, or different parameters that affect the result, you can pull those in. And in the example, we're just doing and adding an offset and scaling the stress, and then selecting whether you want to do both or none in terms of those options. So that will then run in terms of normal answers, but because this is running Python, it's a bit slower. So in this particular example, I've just done that analysis for a smaller part of the model. The way these processes are defined is along exactly the same lines as already defined in the custom SN and custom spot weld. So a file to define what the process is, and then a Python, and quite a lot of documentation on each of those methods and how they're utilised. In the same way, you have the custom analysis engine. So this is now appearing on DesignLife base, so all users will get access to this. And in this tool, you have access to fatigue method, so you can have a custom method and fatigue. You can also have a custom combination method. So you have different methods for custom analysis and different methods for combination. So you can pick custom for the combination method, and then pick which combination method you want. So you can do your own stress combination, and then do your own fatigue analysis and pull your own material data in if you want in your own format. That can go into the standard database, but then you can put any analysis you want based on your own data. And again, adding additional parameters to either of those. So this opens up the software to be used for new method development, for example, but also for method development within universities, but also within companies where you want to test out a new method before you want it implemented in full DesignLife. We're going to talk to us about that. So that's the developments within DesignLife. Have a look at the new glyph within GlyphWorks. So this is a new stationarity test glyph. So you have currently one method. You have some specification of the number of bins for resolution and number of levels you want to take this down to. So how finely you want to chop down your data before you, and what number of levels you go. So if I just run this to show you the result. So basically it takes 2 levels, checks those 2, reduces it to 4, checks those, and subsequently as many times you want. I pick 5 levels before you get down to much smaller, where you started in problems with the repeatability and the stationarity.